Today I will discuss questions of exercise 3.1 NCERT book. All questions of this exercise depends on the basic which we have studied in previous class. Now in the first question, there is a matrix A which has elements 3, 2, 5, 19, minus 7, 35, minus 2, 5 by 12, 5 by 2, 12, root 3, 1, minus 5 and 17. Now in this question, we have to write the order of the matrix A. As we all know that order of a matrix is number of rows by number of columns. In this matrix A, horizontal one is known as row. So it has first row R1, second row R2 and the third row R3. Similarly, first column C1, second column C2, third column C3, fourth column C4. All these are vertical ones. So horizontal one are rows and vertical ones are column. Now the matrix A contains 3 rows and 4 columns. So order of the matrix A will be 3 by 4. Second part of this question asks that we have to find the number of elements present in this matrix. So the number of elements which are present in that matrix is the multiplication of the number of rows by number of columns. So 3 multiplied by 4, that means it will be 12. Then third part is we have to write the elements A13, A21, A33 and A24 and A23. Now what do we understand by this notation A13? Now as we know, position of every element is defined as A, I, J, where I is the number of row, J number of column in which that element appear. Suppose we have a matrix two, 3, 5, 3, 4, 7. Then element at the position A11 would be, A11 means first row and first column. So element present at first row and first column is 2. Similarly, element at the position A23 would be element at second row and third column. This is R1, R2. So second row, first column, second column, third column. So second row and third column, that element is 7. So it would be 7. Now, for matrix A, we can find the element present at the position A13. A13 is first row and third column. So first row and third column is 19. So we can write this as 19. Similarly, A21, second row and first column. Second row and first column. So the number comes out to be 35. A33, third row and third column. Third row and third column. So the number would be -5. Similarly, A24. A24 is second row and fourth column. So the number comes out to be 12. Also, A23, second row, third column. Second row and third column. So it will be 5 by 2. This is how we can find the element present at different positions. If a matrix has 24 elements, what are the possible orders it can have? It can have. To write all possible orders that it can have will be 1 by 24, 24 by 1, 3 by 8, 8 by 3, 2 by 12, 12 by 2, 6 by 4 and 4 by 6. This question also has second part which says that if it has 13 elements, so the possible order of the matrix will be 1 by 13 or 13 by 1. As 13 is a prime number, therefore it can have only a row matrix or a column matrix. So the possible order of the matrix will be 1 by 13 or 13 by 1. Question number 3 is the similar one. You have to do it yourself. Now question number 4. Construct a 2 by 2 matrix where A is Aij, whose elements are given by Aij equals to I plus j whole square divided by 2. Now here we have to construct a 2 by 2 matrix. That means A11, it has 4 elements, A11, A12, A21 and A22. Since it is a 2 by 2 matrix, so it should have 2 number of rows and 2 number of columns. So 2 rows and 2 columns. Order is 2 by 2. Now we have to find the element present at the position A11 by using a rule Aij equals to I plus j whole square divided by 2. So A11 will be equal to 1 plus 1 whole square divided by 2. So the result comes out to be 2. A12, that is 1 plus 2 whole square divided by 2, that is 9 by 2. A21 is equal to 2 plus 1 whole square divided by 2. Again it would be 9 by 2. And A22 will be 2 plus 2 whole square divided by 2. That is 4 into 4 by 2. So the result comes out to be 8. Hence, the desired matrix is A equals to 2, 9 by 2, 9 by 2 and 8. So this matrix would be the resulting matrix. Now the next question is find the values of x, y and z from the following equation. First matrix 4, 3, x, 5 equals to second matrix y, z, 1 and 5. So the two matrices are said to be equal if they have same order. Now in this case, first matrix, the order of first matrix, number of rows 2 and the number of column is 2. So order is 2 by. And the second matrix, it has 2 rows and 2 columns. So order is 2 by 2. Since the two matrices, they have the same order and equal sign is there, that means these two matrices, they are equal. To find the value of x, y and z, we have to compare the corresponding elements, which are 4 A11 of the first matrix should be equal to A11 of the second matrix. That means 4 is equal to y. Similarly, 3 equals to z and x equals to 1. Second part, x plus y to 5 plus z xy is equal to 6 to 5, 8. Now again, these two matrices, they have same order and they are equal also. So the corresponding elements would be equal. So A11 of the first matrix will be equal to A11 of the second matrix. So x plus y equal to 6. Actually, we have to compare the two matrices. So 5 plus z is equal to 5 and xy equals to 8. Now we have to find the value of x, y and z. Now by solving this one, 5 plus z equals to 5, z comes out to be 0. So the value of z is 0. Now from first equation, x plus y equal to 6, we can take x as 6 minus y and substitute the value of x from the first equation to the third equation. Now 6 minus y into y equals to 8. Solving it, we get, that means y square minus 6y plus 8 comes out to be 0. So we have two values of y, minus 4 and y minus 2 equal to 0. So we get y is 4 or y equals to 2. If y equals to 4, the value of x comes out to be 2. And if y equals to 2, value of x comes out to be 4. So these are the values which we can find by comparing the two equal matrices. Now question number 7 is similar to question number 6, so that you have to do yourself. Question number 8, A equals to a matrix Aij of order m by n is a square matrix if Now it's a fill up. What will be the condition when a given matrix is a square matrix? So for square matrix means the number of rows must be equal to number of columns. Now here, if m will be equal to n, then the given matrix A will be a square matrix. Question number 9. Which of the given values of x and y make the following pair of matrices equal? First matrix 3x plus 7 5, y plus 1 2 minus 3x. That means first matrix, order of the first matrix is 2 by 2. And the second matrix is 0, y minus 2, 8, 4. Again, the order of matrix is 2 by 2. Now we have to find the value of x and y such that these two matrices becomes equal. Now by comparing these two, we get 3x plus 7 equals to 0 and 2 minus 3x must be equal to 4. If these two equations are satisfied, then we will say that these two will be equal. Now the value of x, while solving 3x plus 7 equals to 1, we get value of x as minus 7 by 3. But when we solve 2 minus 3x equals to 4, we get 2 minus 4 equal to 3x. That means minus 2 by 3 equals to x. Now in these two, we are getting different value of x. If we get different value of x, these two matrices, they cannot be equal. So the answer is, it is not possible to find the value of x and y to make these two matrices equal. Question number 10. The number of all possible matrices of order 3 by 3, matrices of order 3 by 3 with each entry 0 or 1 is, first part 27, second is 18, C is, these are multiple choice questions. So we have to select the correct answer. Now there is a matrix 3 by 3 matrix with each entry 0 or 1. Let us suppose that there is a matrix CP which is 3 by 3 matrix. So it has 3 rows and 3 columns. So A11, A12, A13, A21, A22, A23, A31, A32 and A33. This is the matrix. Now the position A11 can have only 2 digits, that is 0 or 1. Similarly, A12 can also have only 2 digits 0 or 1. So the possible elements for A11 are 2. Possible element for A12 are also 2. Number of elements. So number of elements possible for this position are 2, that is 0 or 1. So therefore according to permutation, possible entries for the position A11 is 2. For position A12 is 2. Again for A13 it is 2. So 2 by 2 by 2 into 2 into 2 into 2 into 2, 3, 4, 5, 6, 7, 8 and 9. Since it has 9 elements, so 2 by 2 by 2 into 2 into 2 into 2 into 2 into 2, that is 2 raised to the power 9. That means 512. 512 will be the number of all possible matrices of order 3 by 3 with each entry 0 or 1. That is all for today.